Hello everyone, good evening. Let's work on the problems of identifying whether the system is linear or not in this video lecture also. Given a system y of t is equal to 4 into x of t plus 2 into d by dt of x of t, we are going to check whether the system is linear or not, for which we need to consider two signals x1 of t and x2 of t. Let y1 of t and y2 of t be the responses of the system, which is described by a transformation operation for the inputs x1 of t and x2 of t respectively. So y of t, what is given? Y of t is equal to 4 into x of t plus 2 into d by dt of x of t. If the input is x of t or x1 of t, then the response for the input will be simply transformation of the input, so it will become, or x of t in the equation will be replaced by x1 of t, 2 d by dt of x1 of t divided by dt. Similarly, for the input x2 of t, y2 of t will be equal to 4 into x2 of t plus 2 into d by dt of x2 of t. Let us generate a new signal. What was the new signal? Let me call this is x3 of t. Let x3 of t is equal to weighted linear sum of the inputs. A new signal is generated, a linear combination of inputs. Let me apply this through the system, which is going to produce an output. Let me call the output at that moment as y3 of t. Let me call this as response of the system. For the input x3 of t. Let us calculate what is y3 of t now. y3 of t will be simply the transformation of x3 of t applied through the system. What is the transformation formula? 4 times of the input and 2 times the rate of change of the input applied through this. What is x3 of t originally? It is actually generated as a linear combination of two signals weighted by the quantities a1 and a2. So this will become 2 times of d by dt of a1 times of x1 of t plus a2 times of x2 of t. If I start expanding this equation, you will find out that 4 times of x1 of t plus 4 times a2 into x2 of t plus 2 times of a1 times of d by dt of x1 of t plus 2 times of a2 of d by dt of x2 of t. So if I group only, for example, a1 terms alone, where and all you are getting a1, you are trying to combine, or I am trying to extract those terms. So 4 times of x1 of t plus 2 times of d by dt of x1 of t plus a2 is taken as a common factor. We can find out that it is 4 times of x2 of t plus 2 into d by dt of x2 of t. But you can identify this portion stands for y1 of t and this represents y2 of t. So this will be equal to a1 times of y1 of t plus a2 times of y2 of t. So y3 of t is equal to the sum of responses. Therefore, the system is said to be a linear system. System is said to be a linear system. Okay. In the same way, can you just try d by dt squared of y of t plus 2 into d by dt of y of t is equal to x of t. Can you verify whether the system is linear or not? Consider two signals x1 of t and x2 of t. Assume that the responses will be y1 of t and y2 of t. Replace x of t by x1 of t, so that the replacement for y of t will naturally happen, as y of t will be replaced as y1 of t and x of t is replaced by x2 of t. Let me replace y of t by y2 of t. Let me obtain this. So if I generate a composite signal x3 of t, the response is assumed to be y3 of t. So replacement in terms of x of t by x3 of t and y of t by y3 of t will all be done. But if you retain y3 of t, and if you replace x3 of t as a1 times of x1 of t plus a2 times of x2 of t, you will come to know that whether the system will be decomposed or will follow superposition principle or not. Okay, so we can say that if x3 of t is a1 times of x1 of t and a2 times of x2 of t, then y3 of t will also be, I'll write the conclusion here, when x3 of t is equal to a1 times of x1 of t plus a2 times of x2 of t, then the y3 of t, the final equation, should be written as a1 times of y1 of t plus a2 times of y2 of t. If so, you can say that the system is linear. Agreed?